computer. Okay. All right, now we're gonna continue the rest of unit 1. Probably I will have to pause during lunchtime, but yeah. Okay, we're gonna start from the percent yield and then we're gonna end with the Avogadro's number. So percent yield is something that describes a percentage of product that is actually produced. So the words that goes here would be actually, produced after an actual chemical experiment. So that's the word that you want to look for whenever you're looking at reading the question. So the formula for percent yield is percent. Oh, why are you doing this? So percent yield equals to the actual yield in grams over theoretical yield times 100. So that will give you the percentage. So this one was like one of the easy one on unit 1. So the question reads like, if 63.55 grams of Cu was predicted in a chemical equation, so we know that 63.55 grams of Cu was predicted. So that is related to the theoretical yield. That starts with 160 grams of CuSO4, but only 22.88 grams of Cu are actually made by students conducting this reaction in the lab. What is your percent yield? Okay, so I hope you don't get confused by 160 grams of CuSO4 because that's something that you start with. It's not even talking about the product. So this is not something that you want to pay attention to, but the second mass, which is 22.88 grams of Cu, which is actually produced. So the actual yield would be 22.88 grams of Cu. And then theoretical yield would be 63.55 grams of Cu. So your percent yield will equal to 22.88 grams of Cu over 63.55 grams of Cu times 100. And that will equal to 36%. And that's the final answer for this question. All right, you can ask me questions as I go through these, but since I don't see any, I'm going to move on to limiting and excess reactant. All right, so limiting and excess reactant will give you a graph, and then you will be asked to determine if which one is limiting and which one is going to excess. So when examining the concentration versus time, so your graph is going to be time on the x-axis, and then on the left, the y-axis will be concentration. Okay, some reactant, like something reactant starts high and reaches zero before the other type of reactant hits 0 on the x-axis. So the limiting reactant will start high and reaches 0 before the excess reactant. And limiting reactant always runs out before excess reactant. Okay, so if I draw a graph, I am going to use the blue for limiting reactant. Okay, so the graph will look like it will start from this concentration, goes down, and then hit the 0. The blue one will be the limiting reactant. And the green one will be excess reactant. So I'll do the same thing. You can start from lower, but it will never reach 0. And then the products will be in purple. So it will always start from 0 and go up. Okay. So the question says, sketch a graph that on the left that depicts the following chemical reaction where the N2 is the limiting reactant and H2 is the excess reactant. So I'm gonna write that NH3 will be purple. And then excess is the H2, so that would be green. And the limiting would be HN2, which is gonna be blue. And I'm gonna actually make a change to the green graph. Okay, there you go. Okay, so that would cover the limit and excess reactant. It will be pretty easy. You will be given a graph with 3 lines or 4, and then you will have to figure out which one is limiting and which one is excess reactant. And yeah. All right, now we're gonna move on to the percent composition. Let's move on to percent composition. Percent composition shows the percentage of each atom or elements. That is within a compound. And the formula for percent composition is so you will be picking one element in a compound to figure out the percentage of that in percent composition problem. So the first thing you will do for these problem is that you will have to look for the molar mass of this compound. So find the molar mass. Which will be done by you have 2 chlorine, and then chlorine is 35.45. And then oxygen, you have 7 of them. And then oxygen is 16.00. So if I do that calculation 2 times 35.45 is 70.9. And then 16 times 7 is 112. It will be add up to 182.9 grams per mole. And then depending on which one you're asked to do, if the question asks you to find the percent composition of a compound, then what you will do is you will take this number 70.9 as a mass of an element and then divide it by the total molar mass, which is 182.9 times 100. That will be the percentage. Okay, so 70.9 divided by 182.9 times 100 will equal to 38.76%. That will be chlorine, and 112 divided by 182.9 is equal to 61.223. Okay, it will be 61.24% of oxygen. So your final answer would look like 38.76% of chlorine and 61.24% of oxygen. Okay, so those will be the final answer for the percent composition of a compound. Sometimes you will be asked to find the percent composition of like oxygen, like one of them in this compound. So still you will have to calculate the molar mass of a compound. So if we do that, this one is AlOH3. So we have 3 oxygen and then 3 hydrogen. I think that's the bell for the lunch. Hang on. Oh, I solved out the question number 2, but I will explain. Hey. What I did. So in order for us to find just the percent composition of oxygen, stop moving around. What I did was I found the molar mass and then which was 78.01. And I only picked the oxygen's mass, which was 48.00. So 48.00 divided by 78.01 times 100 gave me 61.53% of oxygen. So that would be percent composition of oxygen O in AlOH3. So make sure you read the question carefully. If the question is only asking you for like one element, then you will find a percent composition of a one element. If it's asking you for like percent composition of this compound, then you will list all the percentage of for each element, like question 1. All right, we're gonna move on to empirical formula. Empirical formula is the one that shows the lowest whole number ratio of elements in a compound. It can be found by simplifying the molecular formula. by the greatest common factor. I can also, huh? The copy of this? Yeah, it is already in the class. Like the key is not yet, but I'm uploading it. It can also be determined by the percent composition. And there was a poem to help you remember the step, but I did not do that. So you can ignore that part. Okay, so empirical formula question looks like these. So question one, I'll put it right there. Question one says a compound of iron and oxygen is analyzed and found to contain 69.94% iron and 30.06 oxygen, and find the empirical formula of a compound. I think I will need a little bit more space than that, so let me put some space. All right, so we're gonna start with question number one. Okay. So what we know is we know that there is 69.94% iron, 30.06% oxygen. There was a typo over there. Okay, so that's what we're gonna list. Your step one is to change the percent into the grams. So it will be 69.94 grams of iron and then 30.06 grams of oxygen. And then what we're going to do is we're going to divide these number by the molar mass of each one. So 16.00 grams per mole. Fe would be 55.85 grams per mole. That's going to give us 69.94 divided by 5.5. That's only 1.25 mole. And then 30.06 divided by 16. 1.8788. And then step two, divide by the smallest number, which will be 1.25 mole is smaller than 1.88. So we'll divide each one by 1.25 mole. And 1.25 divided by 1.25 will be 1. And 1.88 divided by 1.25 is 1.503. Okay, so since both of them is not really close to the whole number, what we're going to do is we're going to step 3, multiply till you get the whole number. So if you are ending with 0.5, then multiply 2. If you're getting 0.3 or 0.6, then multiply by 3. Okay, so we're gonna multiply by 2 because it's 1 and 1.0503. So the iron will eventually have 2, while oxygen will have 3. So 1.503 times 2 would be 3. And then These two will be your subscript for each one. So the FE will have 2 as a subscript and O will have 3 as a subscript. So that is how you do the empirical formula from percent composition. I think that's about it. And then question number 2 is asking you, what is the empirical formula of a compound with the molecular formula of C2H6? So what we need to do for this particular question is C2H6. If you look at this subscript 2 and 6, there is a greatest common factor, which is going to be 2. If you divide it by 2 for both subscript, then C will end up with 1 and hydrogen will end up with 3. So our empirical formula for C2H6 would be CH3. That will be our lowest ratio. Okay, so let me square the answers. All right. Okay. Now let's move on to the molecular formula. Okay. So the molecular formula is a simple whole number. What should I say? Multiple of empirical formula. Sometimes the molecular formula is the same as the empirical formula. It can be determined by let me see what she was trying to say. Which is calculated by dividing the molar mass of, oh, okay, molecular formula by the empirical. Okay, I'm gonna look for these two. I'm gonna think about it. It may not be that important. Okay, so the question for this is the empirical formula of a compound of boron and hydrogen is BH3. BH3. Its molar mass is 27.7 grams per mole. Determine the molecular formula of the compound. So whenever you see this type of problem, what you will do is you will calculate the molar mass of BH3. So calculate or find the molar mass of B. So B is 10.81. So I have 1 times 10.81. H would be 3 times 1.01. Which will be 13.84 grams per mole. Step 2, divide molar mass of, so the formula is molar mass of molecular formula over molar mass of empirical formula, which is 27.7 grams per mole divided by 13.84 grams per mole. And that's going to be the ratio. which is 2.00. So that is the ratio. Step 3, multiply the ratio with subscript. And then we'll do that over here. B1 times 2, H3 times 2, which will be 2 and then 6. So the final answer would be B2H6. So B2H6 will be your final answer for that question. All right, now we're gonna move on to the last part, which is about Avogadro's number. Okay, almost there. Avogadro's number is a number of particles per 1 mole of a substance. So it'll be 6.022 times 10 to the 23rd particles over a mole of a substance. So every mole of substance will have that much of particles or things. And these are the units of the particles. So Avogadro's number is used to convert between particles. Units are atoms, molecules, and formula units. In the mole. Okay. So if the question asks you about how many moles of carbon atoms is in 4.72 times 10 to 24 atoms of carbon. Okay, simple conversion, you're given is that, and what you will do is you will use the Avogadro's number. And you will just simply divide it by the Avogadro's number. So it will be 4.72 times 10 to the 26 atoms of C. That's going to be the unit. And then we want to cancel out the atoms of C. And then we want to look for the mole of C. So it becomes 1 over 6.022 times 10 to the 23rd. And make sure you're putting these number into parentheses. So 4.72 times 10 to the 26 times 1 divided by 6.022 times 10 to the 23rd atoms of C. Okay, so what I'm getting is 783.80 moles of C. That's a pretty big number. Let's see, let me double check. 4.72 times 10 to the 26 divided by 6.022 times 10 to the 10. Yeah, that is right. And sometimes you'll be asked to convert from the formula unit, like the particles, to the grams. And that's when you have to calculate the molar mass of it. So what we're going to do for 1.14 is your step 1 is to calculate. Oh, actually, I have been using this find the molar mass. And NaOH. Sodium is 22.99. I go 111. which is exactly 40.00 grams per mole. And step 2, you'll do given divided by Avogadro's number times the molar mass. So it'll be like 4.89 times 10 to the 25th formula units of NaOH, 1 mole of NaOH divided by 6.022 times 10 to the 23rd formula units of NaOH times the molar mass, which is 40.00 grams of NaOH over 1 mole of NaOH. And that will give you the answer. I am getting 3,248.09 grams of NaOH. And that's the end of it. That's the answer. All right. So that closes unit 1. I'm gonna end the video. Stop.